Every modern application requires constant feature updates, but pushing new code to a live production environment introduces massive operational risk. Historically, engineering teams relied on manual deployment workflows. Developers compiled code by hand and physically logged into servers to update files. The process was slow, inconsistent, and highly error-prone. To resolve this, modern engineering replaces human-driven deployments with a fully automated pipeline known as CI/CD, continuous integration and continuous delivery. This animated diagram illustrates the two distinct functional engines of the system. On the left, continuous integration acts as the engine of validation. On the right, continuous delivery serves as the engine of distribution. To understand how this automated assembly line actually works, we have to trace the exact chronological journey of a single code commit from first principles. Removing human interaction from the deployment process is the only mathematical way to minimize operational downtime and scale modern software reliably. The pipeline begins the moment a developer writes new code and pushes it to a version control system like Git. The version control platform detects this new commit instantly. Through a webhook, it fires an event that awakens the CI/CD pipeline. This diagram shows the pipeline's first step. It provisions a fresh virtual machine, creating an entirely empty, isolated environment. This forced reset into a clean room ensures every single build starts from an identical baseline, eliminating anomalies from specific machines. Inside this isolated space, the pipeline checks out the latest source code and uses package managers to install all required dependencies. By enforcing this strict environmental reset, an unpredictable local build is converted into a deterministic, repeatable process. This schematic shows the build automation tool compiling the source code and bundling assets to generate a single, executable build artifact. This unified artifact immediately enters the core of continuous integration, the automated testing gauntlet. The first layer consists of unit tests. These verify that individual functions operate correctly in total isolation. Next are integration tests. This layer ensures different component modules connect and interact without breaking the joints between them. The final layer runs end-to-end tests, which simulate full, real user interactions across the completely assembled application. Running in parallel to these tests, code quality tools scan the entire project for style violations, latent bugs, and security vulnerabilities. Continuous integration operates as a ruthless binary gatekeeper. Its sole purpose is to terminate flawed code before it ever reaches a live server. The operational rule of this pipeline is absolute. If a single test or scan fails, the entire process halts immediately. But if every check passes, the pipeline finalizes an immutable, completely verified build artifact, locking it in place. This diagram shows that artifact being stamped with a cryptographic hash code. It is stored in a central registry, so this exact identical version can be deployed anywhere. This marks the pivot to the CD stage, where infrastructure automation takes control to prepare the release for the real world. There are two distinct CD pathways. The first is continuous delivery. The artifact is staged, but a human must manually approve the final push to production. The second pathway is continuous deployment. Here, successful builds push to live servers entirely without human intervention. This architectural choice dictates an engineering organization's core speed. Teams must choose how they balance manual oversight against pure operational velocity. During the deployment phase, infrastructure automation systematically replaces the live code on production servers. To mitigate risk, systems use strategies like blue-green or canary releases. Incoming user traffic is gradually shifted to the new server cluster in controlled percentages. These phased routing strategies minimize downtime and carefully isolate risk during the highly sensitive update window. Immediately after deployment, active monitoring systems track application health, performance metrics, and user error logs. If an anomaly is detected, automated rollback mechanisms instantly trigger, restoring the previous stable artifact before users experience degradation. Integrating deployment routing with live monitoring creates a closed-loop system. It inherently limits the blast radius of bad code, even after it goes live. This complete flowchart maps the entire journey of the commit, from the developer's push, through the clean room, across the testing gauntlet, and into the deployment loop. It illustrates a strict division of labor. CI handles mathematical verification, while CD handles automated distribution. Compare this fast, automated assembly line to the high-stress, error-prone manual deployments of the past. The ultimate impact on engineering culture is clear. Teams can confidently deploy software multiple times a day without hesitation. By relying on CI/CD, software delivery becomes a deterministic system, ensuring that code flows seamlessly and safely from a developer's keyboard directly to millions of users.